Good day, class. Today we're going to be going over notes on quadratics, and there's going to be a couple of things that you're going to be required to memorize and write down. So one of the things I suggest is that if you're watching this video, go ahead and please bring out some paper and write everything that you're seeing. So if you want to go ahead and pause the video now and go ahead and grab some paper out, and let's start writing. Now that you have your paper out, let's go ahead and have you write this. I want you to know that the standard form of a quadratic is written as f of x is equal to ax squared plus bx. And one of the things that's important about this is that the a, b, and c are numbers. X's are variables. So a, b, and c are real numbers. See how I underline that? And one of the biggest not factors, but contingency with it is that a cannot be 0. You cannot have a 0 because otherwise you would have a linear equation. It no longer qualifies as a quadratic if the a is 0. Okay, great. Alright, so let's go ahead and move on. And again, I'm expecting for you to write all this. Features of quadratic graphs. Now, the graph is called a parabola. So if a is greater than 0, the parabola opens up. That's one thing you got to memorize. And if a is less than 0, the parabola opens down. So you also want to know that part of it as well. So again, write all this down. It will help you in memorizing. Each graph has a vertex, which is the highest or lowest point. So, and really what we're trying to now communicate is we have a vertex. So you're either going to have the highest point, which will kind of be a peak, or the lowest point that will kind of be a valley of that U-shaped graph. And we will find out that we'll have a highest point if a is less than 0, and we'll have a lowest point if a is greater than 0. So you want to make sure that that is also something you memorize as well, especially about the a opening up or down. Now again, if I'm going too fast in the video, just go ahead and pause it and write all this down. Now let's go ahead and talk about the axis of symmetry. Now the axis of symmetry is a vertical line that passes through the vertex of the parabola, which means that in shorthand form, this is sometimes written as AOS, which refers to the axis of symmetry. The vertex in R is this one right here, which is just kind of like a valley. That's the minimum, and here's the maximum. There's the two vertexes, and again, this is the axis of symmetry. Why is the axis of symmetry important? Is because parabolas are symmetrical against the axis of symmetry, and the axis of symmetry is not always our x or our y axis. Sometimes the axis of symmetry is shifted because these vertexes are sometimes transformed, so that means they're moved away from the parent function, and if they are, then we will originate with something that is not the y-axis. But we sometimes have to find where the axis of symmetry is at. Now let's go ahead and talk about how we do that. Given the standard form, the vertex is found using this. This is going to be an important equation you have to memorize, because they're going to be asking you to find the vertex given a parabola. And the axis of symmetry is found using this, which is x is equal to negative b over 2a. Now one thing I want you to keep in mind, now if you notice, see how that and that is the same equation? That means whatever, if you're looking for the vertex, your first value of the x in the vertex will actually be also your axis of symmetry. So sometimes if you have to find the vertex, you automatically find the axis of symmetry because they are the same equation. Now the other part of it, the f of negative b over 2a, for those that are wondering, that's going to produce a value. That value we're going to have to plug back into the equation and see what output I get, or y value in a way. What output is produced from my equation to give me my actual y coordinate in order for me to graph that. So for right now, we'll get into all that, but just write all this down because again, it helps in memorizing. Now, I'm expecting you for the pause the video if you haven't written it all down. Now that you've written it all down, let's go ahead and talk about finding intercepts. Now the y-intercept is just really 0, c. Since we plug it in as x is 0, c is all that remains. So basically, it makes it easy. You just have to memorize the y-intercept is 0c and the explanation is at the bottom. Now the x-intercepts takes a little more work, finding these by solving x squared plus bx plus c. One thing we're going to do to find x-intercepts, you could do it this way, and you could do it either by factoring to find x-intercepts. Yeah, it's going to be a method. Method will be by factoring and saying, okay, when does this equal 0? Another method we'll have is also the quadratic equation. So you may want to write this down. Quadratic. You spell that right? Because sometimes it's easier just to do the negative plus or minus b squared minus 4ac all over 2a. Also, that might be also a better method to go ahead and, well, you're going to see, because sometimes you can look at the quadratic and say, you know what, I'm going to go ahead and factor. That might be my best thing, because then I can find intercepts real easy. Sometimes it's not so easy, and you're like, you know, I can't factor this, and if that's the case, go ahead and use the quadratic formula. It's fabulous. And you can go ahead and get some lovely answers from it. So now let's go ahead and move on and see about how to identify x-intercepts. Now, one of the things that's going to occur is sometimes you'll have parabolas that do a couple of things. You'll have a parabola that most commonly will sometimes hit both. So one of the things you could do is that if b squared minus 4ac is greater than 0, you'll have two distinct x-intercepts. Now, if you find out that when you use this formula and apply this formula, sometimes you might have the case in where, like parent function, you only hit at one spot. And this one I'll put it in blue so you can see the two spots. And if that's the case, then you only have one x. So if it equals 0, if this formula equals 0 here, you only have one x-intercept. It's seen graphically over there. And sometimes you will have the cases that if you find out that b squared minus 4ac gives you something less than 0, we will have something with no blue dots because it does not cross the x-axis, which means there's no x-intercepts in our case. So those would be the three things we need to anticipate that may happen. Now let's go ahead and move forward with this. Graph using the vertex and the axis symmetry and the intercepts. Now it says right here, there's a couple of steps and I need you to write all this down because it's going to be important when you're graphing using the vertex and the axis symmetry and the intercepts. This means that I won't be using my calculator. This means that I'll be physically using a couple of things. Finding the vertex. And if you remember, the vertex is negative b over 2a and f of negative b over 2a. That's one thing I'm going to be using. Axis of symmetry, which is just x is equal to negative b over 2a. And lastly, the intercepts. And we'll get these from either factoring or quadratic. So those are the three things we'll be needing. And using these three things, we can go ahead and actually graph something that is pretty good quadratic. So now here's the steps. Find the vertex, axis, symmetry, intercepts using the methods already described. So those are the three methods we wrote already. Graph the vertex and the axis of symmetry. Graph the intercepts using the axis of symmetry to find additional points. If you do not have 5 points in your graph, plot an additional point by plugging in any value for x that's relatively close to your vertex and a point opposite of the x-axis of symmetry from it. And we'll get into details on how to do this because it looks like you need about 5 points. So let's go ahead and start using our practice. Go ahead and write this down, and we're going to go ahead and actually use the steps described above to go ahead and actually do what it's saying at first, graphing the axis, graphing the other things, and then we'll get into the whole thing about the how to come up with some points. So first, why don't we go ahead and start with the vertex. The vertex, now the first thing when you look at this equation is to go ahead and determine, or make the, like if you're not very accustomed, make sure you know that this is A, B, and C. Because in our vertex, we will go ahead and write, it would be over 2A, and the F of negative B over 2A. I want to go ahead and do that first. Now B is negative 8, so that means I'll have a negative 8 all over 2A. So it'll be 2 times, in this case, 2. So this is going to result in an 8 over 4, which means I have 2, which means that my x, well, first of all, my axis of symmetry, and I'll write it here, AOS is going to be 2, and my x value is actually going to be 2 as well. So in this case, I'll have 2 down here, but I really don't want to write 2 yet. I don't want to write my points yet, but this is going to be this value that's going to go right in here. That's what that's going to be. Now, knowing what the f value is, f is 2, right? So actually, I'll write it down. 2, f of 2, and then I'll erase this part of it here. But I want you to see that now, since we know that f is 2, means that this is really going to be 2 here. Which means that this is really 2. So we'll have 2 times 2 squared minus 8 times 2 plus 3, which means that comes out being 8 minus 16 plus 3. So I'll end up getting, and I'll erase this because I want to make sure y'all have a clean graph. Oops, not that. No, let me undo that. Okay, there we go. I'll have a negative 8 plus 3, which means I'll result with a negative 5. Which means that in reality, it's really 2 to the negative 5. So I have my vertex. I have my 2 important things. I have my axis of symmetry, and I have my vertex. So I can start at least graphing those. So the vertex is going to be 2, negative 5. Which will be this point here. My axis of symmetry will always pass through a vertex because of that unique feature that they both have this in common. Axis symmetry and the x are always going to be the same. Now, what do we do from here? Well, one of the other things you could do is let's use our y-intercept. Now the y-intercept on this one, if you remember, y-intercept is just 0, c. So that means in my case, it's going to be 0, 3. It's my y-intercept. Which means that this point is going to pass right up here, actually. So we'll have a pretty narrow parabola in regards to what we're doing. Now let's go ahead and find the x-intercepts. Now a couple of things here. Again, we could factor this, and well, let me pause this because. Okay, we're back. Let's go ahead and continue with this so y'all can see what do we do here. Now, x-intercepts. I'll go ahead and I want to clear up some space because I do want to go over this with you. I'm going to use a quadratic formula to figure out the x-intercepts. So we wrote all this down just because I'm running out of space, so I need to erase it. I know I have my vertex, we did all that, but on your paper you have some extra space. You have this one advantage about what you have compared to what I have. So let me clear this up a bit. Let's see, clear this, and this. And now, move forward to find my x-intercepts. Now the x-intercepts on these are going to go ahead and be, use the quadratic formula. They're going to be plus or minus c squared minus 4ac all over 2a. Now, negative b means that I have 8 plus or minus negative 8 squared minus 4 times 2 times 3 all over 2 times 2. So which means that all this inside is going to become 64 minus 8 minus 24. And over 4. Let me go ahead and just shift this a little bit. And we'll get the 8 plus or minus. That's going to result in the 40, yes. 40 all over 4. Which means that we really have 8 divided by 4. I know some people were wondering how I felt tempted just to write 2. But I really don't want to do that. 4. It'll be 2 plus or minus this square root of 40 over 4. Which is really, well, let's go ahead at this point, start using your calculator here. And what I mean is that part over there, and let me go ahead and make sure I have the right thing selected on this one, which I do now. Let's quit this and type in this. Okay, so let's find out the square root of 40. Oh, square root of 40. 6.32 divided by 4, and I have 1.58. So this is plus or minus 1.58. Ooh, I moved everything. Give me a second. 1.58 plus or minus. So what does it mean? This means that in my last command, I'm going to have 2 answers. My 2 answers is going to be, one of them is going to be the plus part of that. So let's figure out what that is. Let's get the answer. Ooh, I'm writing. Hold on. Clear that. Go back to that. Now let's actually do plus 2. So one of my intercepts is going to be 3.58. Hold on, let me put this back. That looks like I'm messing around with it. There. Okay, got it. Get 3.58. And the other one's going to be minus 2 of that, which is going to be then... actually, you probably could just do it in your head. 1, 2, which is going to be, should be negative 0.58. Or negative 1? Is it negative 1.58? Let's just verify. I'm going to be giving you something that's wrong. So the verification means 2 minus 1.58. And oh no, it is 0.42. Okay, so that means in this case it's 0.42. Oh, something isn't. No, that is it. It is 0.42. So let's go ahead and write down our 2 intercepts. 0.42 is about here. It looks about right. And the other one is 3.58. So 3.58, which is here. So far, pretty good as far as what we're doing. Now, if you if you need more points could be generated using the equation up above. So if we wanted to, we could go ahead and, well, we found it for what 0 is. But since we know that 0 is that, remember how it said that whatever one of it is, it's the exact same on the other? That's true. So for 2 this way, we'll have another point over here. So now I have a total of my 5 points. So it makes it easier for me. Graph this parabola to look like this. And that's how you do it by graphing. I have my 5 points, and I also have everything that was requested from me. Alright, fantastic. Let's go ahead and move on to the next one. Let's have the next one, please. Now, to graph transformations, you need equations in vertex form. Now, this is something, well, not to say new, but I know that vertex form is something that we're going to have to get accustomed to doing. Now, one of the things about vertex form is that it's slightly different as far as the other one. Vertex forms, we're going to be using something that we learned just previously of transformations on what A, H, and K does. You already know the effects that it has. And this, one of the things about, nice things about vertex form is that the vertex is really easy to find, because all you have to do is just take the H and your K value, and you find the vertex form. Now, not all equations are in vertex form. As you saw, the first 2 that we dealt with were in standard. So there must be a process how to convert it to vertex form. And this is the process I need you to write down and memorize. Oh, there we go again. Hold on. And we're back. Now, this is what we're going to do. First of all, we're going to factor out the a from the a squared plus x squared plus bx, leaving the c outside the parentheses. So what are we talking about? Well, first of all, let me go ahead and write the standard form of the parabola ax squared plus bx plus c. We're gonna, they want you to factor out the a, so basically whatever number this is, whatever the a is there, we're gonna have to factor that out. And this means that we're gonna be left with the new b, because this b, or it's gonna contain in the factor out form a times, I guess, the b, because this value will be the same in our case, and this a will be factored out in a way. Remember, the biggest difference is that this is a new b. And one of the things you're going to do is that we're going to do something called completing the square, and we're going to do that by doing something special. We're going to go ahead and be dividing by 2. So whatever the new b is, new b, and divide that one by 2. Okay, and then after that, squaring it. New b. And you know what might be better for y'all? It's for me to change the colors from this b on this b. Let's make that one blue. Instead, I'm not giving blue here. Let's make it purple then. One of the things is that this is a new b, and that's a new b. And that's one of the important facts we got to keep in mind. Because, and then you'll see what I'm talking about as you go through. Factoring out the 2, squaring. And then we add that number to the parentheses, but subtract the a times that number to keep everything balanced. And this is better explained just on an actual problem. And we rewrite your parentheses as 1 factor squared and should have the vertex form. So let me show you what I'm talking about, which means that I'm also going to take the other things that we were working with. And notice, actually one of the things I could do is probably select them, take them with me. Let's see, selection tool, because I want to show you what I was trying to explain here. Oh no, I'm just moving that. Oh no, it does. It takes away. It doesn't do everything at once. That's all right. I'll figure out how to do that. Let's go ahead and move forward, and we'll show you what I'm talking about. Okay, so we have this a squared plus b squared plus c. Now remember how we said that, like the other equation that you had? You know what? I think I should be able to change the view on this. I'll show you what I was doing here. Little page. Turn it on for a second. Okay, good. Now, remember I said we have this part right here about the a and the a? That's like this first part right here, and really, that one of the things that's going to be factored is going to be 3 and times, and I'll change the color to match that. Remember we said that was going to be 2. It's going to be a and 2. That's going to be factored out. So in our case, we'll actually end up with 3x squared minus 2x. And I'm going to leave a space here because that space is going to be necessary to complete the square. And we're going to do this part of it here. See, I'll move it right out, that part. Yes. Lovely. Love this, because now you can see what I was talking about. Now, that part of it means that I take this new b, and this is the new b right here. I should change the color on that one too. Let me change the color, make that purple again, because that b is important in our process of doing this. Okay, that's here. That new b will be applied using that. So we'll have 2. Let me go back to my other color. Divided by 2 squared. And this is going to produce 1 squared, which means it's just 1. Right? So that means that this part of it right here, this is plus 1. So that's my magic number, as we're describing in this one over here. But one thing, See step 3? Step 3 means we have to add the number of parentheses, but subtract 8 times it. Now, why must that occur? Well, we can't just make up numbers like what we're doing there. In our process, especially how to set up this equation is, we need to make sure that, and let me show you what I'm talking about, that whatever a times the number, okay, so this is my number, my perfect square number. This is my a, right? A we said was 3. I'm going to do 3 times 1 and subtract. So this is what you'll have. X squared minus 2x plus 1 plus 4 subtract 3. And actually, you know what? If you want, change the color in that one and make sure you understand that this is, let's subtract 3. Now, why are we doing this? It's because this inside the parentheses is a positive 3, but if I had to distribute it. And really what I'm doing is that I can't just go ahead and make magic math. What needs to occur is for me to keep everything balanced, which means that if I make something occur, I got to make sure that it shows up. And this is similar to this kind of principle. Suppose I just had f of x is equal to x. This is the same thing as me writing plus 3 and minus 3. Why? Because I know that these will cancel out. So and it's not like I changed my equation. Now, if I did this, and then I had to put the minus 3 and left this one out, then I'm making a violation here. This is magic math. And I don't like magic math. I'm going to say it because it doesn't entertain me. Is that it's not right. So that's what needs to occur here. So that means that in our case, we'll be left with 3 times x squared minus 2x plus 1. Oh, well, actually, sorry. Last thing, we have to rewrite our parentheses to factor squared, and you should have the vertex form. What am I talking about? Okay, now, this is one of the nice things about when we do this, is that first of all, okay, this factors now, because we created a perfect square. And the way it factors is like this. This becomes 1. Now this minus is what determines that that's minus, because we have to get back that. And actually, one of the things I probably forgot to, I didn't forget to do, but what needs to be done, so I was writing it back again, the equation. That square is really on the outside. So here's my perfect square. This binomial that I just wrote will produce back this. Actually, I could probably draw like a little double arrow to produce that back. And if you don't believe me, try it. But we'll see how you're saying, Mr. Sandoval, I do believe you. Now, that is plus 1. Now, the nice thing about this is that I have my HK form of the equation. So now that I have this vertex form, I could easily say the vertex on this one is at -1, 1. And it's going to be compressed by 3 and other things that have to do with it. But that's one of the things we'll have. We'll have the vertex form of that. And that's one of the things that will help us with doing this. Alright, excellent. Alright, let's go ahead and move forward and make sure that that's all they really want you to do. And we'll practice another one. Now, we'll use the same steps that we were doing before. So you have to realize that we're going to do the same thing here on this one. Now, same thing. You see how, remember how we started with that one? We're going to factor out the a. That was the number 1 thing. This is really going to be then a half. If I factor out a half times 1, because the half is going to be factored out. So a half times 1. Actually, no, that's not true. It's actually going to be, because a half times 1 actually produces back a half. So, and I can't just make something like that up. One of the things that needs to go there is 2. 2 is appropriate number because a half times 2 will produce back 1. So, well, and actually I want to make that in red because I was trying to say that purple is newbie. So that will produce back 1. Okay. Now with that in mind, we're going to factor out this a half. This first thing is going to be factored out in this one, so let's factor that out. We're going to end up with a half times x squared plus 2x. Let me just make sure that I'll leave a space here because remember we're going to complete the square plus 2. Now, let's take the b value again. It's going to be my 2, my new b. Take that and divide that by 2 and squared. So, in this case, we're going to end up with 1 again. 1 squared, which is also 1 again. So it means that this is really 1 there. Actually, no, I like to be color consistent with what I've been doing. So, let's put plus 1 in here again. Now again, we're going to complete the square on this. So the nice thing about completing the square on this one is that now we'll have a half x. Now you see the plus? That's why there's no way this is plus 1. Because that determines my sign for my completing the square. And remember, a half, this last part over here, is also going to have a times that new b. So it's going to be a half times 1, which is a half. So I'm going to add a half here. Now, I can't just add a number and a half together. I have to get a common denominator. This is really 4 over 2, which means I'll get a half x plus 1 squared plus 3 halves. Now that I have in vertex form, the lovely part about vertex form is that now I can get my vertex pretty easily. Vertex on this one is going to be hk, which is 1 3 halves. Fantastic. It makes it easy for us. Yes. Lovely. Alright. Now let's go ahead and go on to the next one. Let's move forward. And now I'm going to take away the full view because I want us to now we're going to do something that's not necessarily related, but just a little different. It says finding the equation of a quadratic in standard form and using the vertex and a point. Really what we're going to do is that we're going to be given the vertex and a point, so we're going to be given hk and a point, xy, and with these two values you can go ahead and find the equation. That's one of the things we're going to be able to do. Equation of a quadratic in standard form using the vertex and a point. And the first thing we're going to do, we're going to substitute the values for the vertex h and k into our vertex form of the equation. After that, step 2 is going to plug in your additional point x of f of x to find a. After that, you follow out your x minus h and combine like terms, and then we end up with our standard form. So let's go ahead and write all this down, and let's perform an example. Now, let's go ahead and first of all write the vertex form. So, for example, find the equation of the quadratic in standard form with the vertex 3, 2 passes through the point. So the first thing is we're going to go ahead and write this in vertex form. So I now have a x. Actually, you know what? I should use a different color. Too much black ink, so you won't be able to tell the difference as well. Right here. F of x. So we go to a x minus 3 squared plus 2. And another nice thing that I have is that I have also f of x, and f of x. It's right in here. So that means that makes it easy to also do 10 is equal to a times 1 minus 3 squared plus 2. So that means that this is really a, let's see, I'll just go ahead and just show you here because I want to write the answer there already. Okay, this is really negative 2. Negative 2 squared. Well, I won't go so fast. Let's go ahead and write down the actual thing. Negative 2 squared plus 2 is equal to 10. And then after that, I'll get a is equal to 4 plus 2, 10. So in our case, we're going to solve for a. So all you got to do is subtract 2. And I know most of y'all are probably used to custom seeing this really written like this. I want you to write it on your paper too, 4a. That's what most of y'all saying. Because I know some of y'all are probably looking at a little weird. Okay, so there, divide by 4, means my a is really 2. Okay, good. That was my missing piece in finding how to find this quadratic up there. If you notice, just about everything's here in the vertex form except this one, where my a is. So with that in mind, go ahead and do some erasing. Let me erase this first. Get my 2 there. I want you to not to erase. I want you to write new. And I want you to erase what you've done so far. I'm erasing just because I want to save space. So, that. Let's go ahead and FOIL it out, and we should get the standard form of what it is. So let's go ahead and do our FOIL. X minus 3, x minus 3, and plus 2 still there. FOIL means I get x squared. I'll put brackets there. Minus 3x plus 9 end up with x squared minus 6x plus 9. Now this 2 needs to be distributed out. 2x squared minus 12x plus 18 plus 2. Which means that my grand finale, my solution, is just going to be just combining these last 2 like terms, which would mean 2x squared minus 12x plus 20, and I have the standard form in my equation, and I did that just from the vertex and the point. That's how I accomplished this. So yes, it's possible, and you saw that you're going to become good at doing this. Now we're going to do some application problems. We're going to use quadratics to find the minimum or maximum. Remember that you will find these as a y value of the vertex. So we'll try one together on the worksheet before each group begins their problem to teach the class. Oh, okay, that's interesting. So let me go find the problem and see which one they're talking about. Okay, great. Let's go ahead and try an application problem. Now, with an application problem, you're going to be given an equation. Like in this case, I'll come up with an equation for you. So, just to kind of demonstrate an example. And the equation I'm going to use is this one. I'll use that x expressed as negative 20p plus 500. That's how, and really what we're doing is that we're expressing price in dollars of a certain quantity sold. So this is price, and this is quantity sold. And typically you're also going to be given a kind of like a domain restriction. You got the equation, you got a demand equation, which is that one, and you'll have a domain restriction regarding to the price. So that's the revenue right there. Well, not the revenue, but the units or PS. Now let's now actually write down the equation. We have that the revenue equation is actually going to be x times price. Now the thing is, given the equation how it is, I don't have that in terms of p. Which means that, let's go ahead and get that in terms of p. So let me go ahead and rewrite that x is equal to negative 20p plus 500 and solve for p. So first of all, subtract 500, x minus 500 is equal to negative 20p. And then we divide by negative 20, divide by negative 20. And we'll end up with P, which is negative x over 20 minus 500 over 20. So that's going to be my x value, and that's one of the things I'm going to use. Well, the nice thing is I can simplify that negative 500 over 20, and that should actually come out being, well, actually it should be, I lost my negative for the 20 here, negative there. I transported the other one but not there, and I'll find out that goes in 25 times. So I'll have negative x over 20 plus 25 is equal to p. Yeah, great. Now with that, let's go ahead and actually now, to find out my revenue equation, I'm going to substitute that back in here. And I'll get r of x is equal to x times negative x over 20 plus 25. And then from here I distribute the x, which means I get negative x squared over 20 plus 25x. So now I have a revenue equation that I can count on to use for certain equations. If you're going to be asked something like using this equation, if you're asked this problem similar to your homework, which is problem 75, ask you what is the revenue at 20 units. Well, that one's actually not difficult to solve because all you have to do is just type in 20 inside this part. So all you have to do in that question is just go ahead and do. So when you do like B, on yours you're going to do negative 20 squared over 20 plus 25 times 20. So, and then you just get a numerical answer for that. Now, let's talk about what C. So, what quantity X maximizes revenue? Now, for that one, in order for you to find that out, oops, the bell's ringing there. Okay, but in order for you to find that out, I think one of the things you need to do is actually get the axis of symmetry to find out where is it, like what x value will maximize revenue in your case. So in our case, one of the things we're going to do, we're going to do negative, in this case, negative b over 2a. Oops. Let's fix that. Negative b over 2a. Let's see what I get there. So like in this case, my negative b is going to be 25 all over 2 times a, which is going to be now, which is actually negative 1 over 20. That's what that value is. And this should produce a numerical answer. Let's go ahead and see what that is. Ooh, I want to do that. Minimize that, but okay, so let's see. Just type the negative 25 divided by, yeah, 2 times negative 1 divided by 20. So that produces, and that produces 250. So, oh, I'm right back on here. So that means that that's going to be my point where I get the maximum revenue. It's from the axis of symmetry. So if I was going to go ahead and re-put that in as an R value, as far as, and the reason I'm doing that is because I want to go ahead and see what is the maximum revenue. Let's go ahead, and really what's going on with this application problem is that quadratic will, since you see how the a is negative, this quadratic, if I was going to graph it, will be looking like this. So we're trying to figure out where the maximum point is, and that's going to be found at the axis of symmetry. So that 250, that x value will be the where I should get the highest amount. So using that 250, using my original equation, which was negative 250 squared divided by 20 plus 25 times 250 means that my maximum amount of revenue is going to be 3,125. And that's how I get my maximum revenue. Now, as far as the next part of this, which talks about part, it says, like D is going to say, what price should the company charge for the maximum revenue? Well, we know that x is at 250, right? So if that's the case, so x is at 250. I know my original equation was down over there. We have x is equal to negative 20p plus 500. I'm going to go ahead and actually now set that up. I know what, well, actually no, I'm going to use the other equation. The one where I saw for x, which was the, let me erase this. The other one, which I have p is equal to this part of the equation right here. I'm going to use this equation to answer question D. Question D on this one means that I'm going to go ahead and type in negative 250 over 20 plus 25. The price I really should be charging for this product ends up being is $12.50. So, and that's really all I did, just use the computation of this to produce this. Okay, fantastic. I hope this video has helped you, and if you have any questions, always feel free to come see me.